Okay. 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 We're back. Oh, we're back, right? Yeah, the stream did in fact crash. It should be back now. Unfortunately, the chat, I can still see the chat, but you won't be able to on like the stream itself. Because that every time I've tried to move it, it has just crashed OBS. So yeah, unfortunately, moving it around will cause it to literally just crash. I have no idea why. I'm gonna turn the music up a bit. Yeah. So anyway, now you can see that oh shit. Alright. So if we go time again, it shows you the time. Right? And it is in fact 8:12. So yeah, that does work. That's not anything new. Well, it's new-ish, but not anything like really new. Make clean. There we go. Just clean it up. So yeah. So I'm going to commit now. Before I do, let me go into the README. We have the Syscall interface, so we no longer need that. And milestone reached higher half kernel. I guess we're just going to leave that there, but we no longer need Syscall in the README because, well, we've got it done now. So now what we do is we will go added Syscall interface 0x80. Oh, I guess 0x80 with Syscall, right? Exit sys get PID. Alright, so now we'll go commit. I would like to stage all of them. And now we push. And so now if I were to reload, yep, there we go. Added Syscall interface. That works. Alright, hang on. Hang on, no it's not, no it's not. Oh, for fuck's sake. Oh, god damn it. I'd said it's private. Alright, so now we're back to being public. God damn. Where'd my water go? Oh, down here. Alright, guess we're listening to some Parkway Drive. Now, if YouTube's copyright system doesn't flag this, yes, it has been fixed. I need to... Can you hear the music? So I just pushed, unfortunately, I did accidentally, every single time I go to stream, it automatically configs itself to private. So, yeah. Also with the music, if you want me to either turn it down or up or whatever, I can obviously change that. Then, okay, alright. Alright, so now what we're going to be working on is user mode, which will be in ring 3. Hang on, sorry. Okay, so what... Is the stream still up? Or has it been, like, soft? I think that might be in the playlist. I'm just going through my liked playlist, so... And 100%... 100% there's fentanyl in my liked playlist. Let me... Fuck it, video nasty. Alright. Okay. So now we will get started on the user mode. And so right now everything runs in ring 0, like I was saying. It's like the most powerful mode like the CPU has. So code in ring 0 can literally do anything, like touch, and like memory, like talk directly to hardware, and even, get this, crash the entire system. If one small program has an error in it and it runs in ring 0, it can crash the entire kernel, like the entire system. And for the kernel itself, the kernel running its own programs that it has, that's fine. Obviously, because if it's going to be running in the kernel, it's not going to crash, right? You don't want it to, so you write it to not crash, and it doesn't change. So, you know, you aren't an error. But anyway, so it's fine with the kernel, but something I don't want to give to just like, you don't want to give it to like random programs. And so, because this is an x86 operating system, and which is based on x86 CPUs, x86 CPUs, like I was saying, have 4 levels. They're called rings, which you have 0 to 3. you know, 0 is the most powerful, which is the kernel, and ring is 3 is the least powerful, which is user programs. Rings 1 and 2 do exist, but no one really uses them. They're usually used for like hardware drivers and stuff like that, which we're doing that in ring 0, which is what most things do. Most like operating systems, like x86 operating systems, have all their drivers in ring 0 with the kernel, and that's what we're doing as well. And then ring 3 is, yeah. So I think of it like a building, right? With like security levels. The kernel lives in the server room, right? The server room, that obviously has access to everything. And user programs live in the lobby, let's say, right? They can do basic stuff, but if they want anything, video nasty. Can you guys, yes, can you hear it? Anyway, so like, think of like the user programs, right? They live in the lobby. Like they can do basic stuff, but if they want to do anything sensitive, they need to ask security, which is the kernel, through like a specific window. And that specific window is the Syscall interface that we wrote. And so when a user mode program tries to do something it's not allowed to, like, you can barely hear it. Right. Anyway, let me just... yeah. I do say like, hey, can you guys hear? And there's like one person here. Anyway. So like if the user mode program tries to do something it's not allowed to, like access kernel memory, or... Can you still hear me? Because I feel like I'm going to turn it down slightly actually, because hang on, let me have a listen. Right, hang on. Let me actually give me a second. I'm going to turn it down slightly actually. No, actually. Yeah, no, that's fine, actually. That's completely fine. Yeah. Alright. Okay. Well, let's just hope that YouTube copyright doesn't bum me over. So if it tries to, like, if user programs try to do something it's not allowed to, like access kernel memory or talk to the hardware directly, the CPU will then immediately stop it and then hands control back to the kernel. So it's a way of, like operating systems use all the time, it's a way of protecting itself from, like, buggy code or malicious programs. Right, and so we need 2 new GDT entries. So we already have kernel code and data segments in ring 0. We need to add ring 3 versions of those segments. And then a TSS, which is a task stage segment, which is a special structure the CPU uses to know where to put the stack when switching from ring 3 to ring 0. And like without this, a syscall from user mode would have nowhere to put its stack, like at all. And then a jump to ring 3. That's the third thing we need to do. To actually get into ring 3, we use iret, which we did in ISR, didn't we? Yeah, iret here. We need to actually jump to it. We use iret with the stack set up to describe a ring 3 execution environment. So the CPU sees the privilege level. And yeah. So that's what we need to work on. I'm just trying to make sure that the stream is healthy. Good. Okay, so now CPU gdt.c. Now we go hashtag So change the entry count from 3 to 6. And then before GDT init, so right here, struct TSS underscore entry. Oh, did I get a message? Oh, well, yeah. Okay, so this TSS entry, and so now in here, yeah, let's just do this. All right. We do want ESP0, so that is the kernel stack pointer for ring 0. Kernel stack segment. Right, and so now we have ESP1, SS1, ESP2, SS2, CR3, EIP, E flags. Now we want EAX. So basically from what I might do is I might streamline this a bit actually. So from here we'll go EAX, ECX, EDX, EBX, ESP, EBP, yeah, EBP, ESI, EDI, yeah, ESCS, SS, DS, FS, and GS. There we go. So now you're on to 32 underscore T, LBT, trap, and I'm at base. There we go. There we go. Packed. And now we go static, struct, entry, TSS. Right. And so now we update GDT init. So entry 1, 0, entry 1, 0. Okay. And so now we go entry 3. And I'm gone. No? Oh, well, the last one. Yeah, I'm not sure. Anyway, so this will be entry 3, which will be user code segment, which will be GDT set entry 0xUF. Is this correct? Yeah, it is. And so now entry 4, user data segment. Yeah, this is correct. So now we go entry 5, TSS segment. So this one will be different. So entry 5 will be UI into 32, and let's go TSS base equals UI into 32 and TSS. UI into 32 TSS limit equals size of, now it doesn't equal size of TSS, it equals size of struct. I don't... What the fuck are you doing? What? Struct TSS entry -1. That's what I wanted. And so now GDT entry TSS 0x89. Now I actually want this to be 0x00. I'm gonna skip this song. Let's go ahead. Fuck it. I'm gonna be seeing this guy later in November. His name is Robbie Williams. Right. And so now we go set up TSS point to ESP0 and so ESP0. No, not point to ESP0, point ESP0 to top of the kernel stack, SS0 equals 0x10 kernel data segment selector, and so now we go. So we'll go TSS.SS0 10, and now TSS ESP0. Now this will literally just be 0. Set it properly. Now we will. So we'll set this properly. This. When we create a process, and so now TSS dot base size of struct TSS entry. The end of GDT init after GDT flush. Load the TSS by going ASM volatile. So that'll be LTR %0. Now I actually want this to be R, and then in here we go int16 T. Now that's LTR, and this is actually not %% AX, it's %0. 0x2b, no, that's not meant to be 2b, that's meant to be 28. Right, and so 2a is this selector entry, selector for GDT5, GDT entry 5. Each entry is 8 bytes, so entry 5 has an offset of 5 multiplied by 8 equals 40 equals 0x2a. Yeah. So yeah, this song is great. It's called I Love Judy Hopps. So gdt.c, which we are in. So void. I think this is correct. TSS set kernel stack int 32t stack tss esp0 equals stack. Yeah. Okay. Hang on.
truth is, I thought it mattered. I thought that music mattered.
Alright. Alright. Okay, so now we go into GDTH. And now we go void TSS kernel stack, you want to 32 stack. Alright. Alright. Now, let's see, make run. Alright, let's just do the time test. There we go. Now we haven't messed with the file system at all, so that should still work fine, so I'm not going to bother with testing that. Nope. Okay. Alright. So this isn't the entire, obviously, it's like the bottom of the night, and I'm never gonna win. This club hasn't come quite the way I want it to be. Tell me what you want. I want a brand new house on an episode of Cribs and a brand new baseball ring and a king size tub big enough to 10 plus me. So what you need? I'll need a credit card that's got no limit and a big black jet with a bedroom in it. I was doing a mile high club in 37,000 feet. Good. Cut my hands, drink my name, cause y'all don't wanna be rock star, little top, top 50, cause the girls come in the book and shit. Come So we go into kernel, new file, and we go usermode.h, usermode.c, speed down. So this if and use mode H, define use mode H, rest of the INTH, void jump to user mode, the INT32D, EIP, the INT32 ESP.
It's just one of those days where you don't want to wake up. Everything is fucked, everybody sucks. You don't really know why, but you want to
Just rip it towards her. Alright. Fuck it, I'm gonna put in my top songs of 2022. Sure, why not? Okay. So now we're going to use mode C. Oh, let me save this first. Hashtag include. Use mode H. And now we go hashtag include GDTH. User segment selector. Bring down to the bottom of the bottle. So now we have each. Okay, fuck's sake. Nah, you already know that each GDT entry is 8 bytes. I was telling you about it earlier, so yeah, we don't need that. Hashtag define user code segment. Well, I don't want user code segment, I want user code seg, just to keep it short. 0x1b, 0x23, and then we go void, jump to user mode. Let's just get rid of all this. I can just do this. Hey. So now we go tell the TSS where the kernel stack is. So syscalls. So syscalls. Switch back when needed. So TSS set kernel stack. I don't want it to be this. I want it to be I want it to be ESP. Right, so now to ring 3, we use iret. That looks pretty good. User data segment selector. No, it doesn't. It doesn't look pretty good actually. It expects the following. Well, it doesn't expect the following stack iret, which pops actually. So which pops EIP and SS. Alright, and so now I'm doing fine. Let me just, so this is the user data segment selector, so no, actually, let's, yeah, ASM volatile. Yes, yes it is. MIV. This is percent 0 EAX / N user data segment selector EAX DS / N, which set data segment to ring 3. Now let me actually double tab these quotes. Shit. So let me just go. So now AX ESN FSN AX GSN push 0 N, which that is, yeah, push user data segment selector, which is SS, so that is user data segment. So yeah. User data segment selector SS. Now, should I be doing push L or push? Let me just try push. So user stack. So yeah, user stack pointer ESP, and so now push F / N. So this is E flags, so current flags, and now we go pop EAXN. Yeah, so it's, yeah, pop EAXN, and then yeah. So basically this is make sure interrupts are enabled in ring 3. So make interrupts are enabled in ring 3. So push EAXN. Don't need anything there. It really loves putting in E flags. And so now push %2, which is user code segment, yeah. Now push %3, which is EIP, user instruction pointer, which is actually, yeah. And let's just slim this down. Go watch it then. It's like actually, like, I love it so much. This is just entry point. And entry point. And now obviously we need iret. Which that, yeah, it does jump to ring 3, but anyway. Okay, so this is I user data seg r esp I user code seg r eip. Yeah, that's perfect.
You are the spicy little demon with the bleak blonde hair, feeding for some semen when I caught your stare. Thought it might be love, but you
Alright.
went too far. Fucked all my friends and blew up my car.
So now I need to go make file and then objects. Let's just go.
You stepped on my nuts and you tore
Obviously we'll go user mode O. And so this, let's put this, oh for fuck's sake, I keep hitting tab by accident. Mr. Did I end up entering user mode? No. User mode O. So yeah, kernel user mode C, kernel user mode H. I again don't need the drivers part. So it's, yeah, there's user mode C, user mode H, IDTH. Alright. Hey! Okay, so make disk, and now we're going to make run. Hey! So now make clean. Now we'll write a small test function to actually jump to ring 3. So even though the difference between squid and calamari, there is a difference. I don't know what it is though. I know there is a difference. Okay, so now in kernel.c, obviously we need to go jump. What? No, okay. Hashtag include user mode H. Alright, and so now kernel. So before kernel dot main, well not kernel dot main, kernel underscore main, we want static void. No, we don't want that. We want static void user underscore mode underscore test. So terminal write string. No, we actually don't want this code. Alright, so now we want ASM volatile. Squid have shorter wings on their head, while calamari have wings along their whole head. Oh, well there you go. So we want to go MOV. No, this will be $0. Some percent EAX/N. So this is syswrite. System call number 0. Yeah. So now we go. MOV $MSG EBX. So this will be buffer. So MOV. So 13 ECX, which is basically what I want, except for it's actually not 13, it's 19. And so now int 0x80/n. That does call the kernel, but whatever. There we go. Static const char message hello from user mode. Let's and so now we go make ISO, make disk, make run. Oh, hang on a minute. No, I'm an idiot. Yeah, because I haven't actually done it, so it's right before the halt loop. Oh, hang on. Ah. Oh, that's the difference. Wow. Oh, wow. Damn, I would have actually never noticed that. Wow. That's cool. Alright, so PIT in it. So it would be like right before here then, wouldn't it? Yeah. That's caps lock. I want simple stack for user mode test, so we just go static UINT32 user stack 4096 096, and now we go INT32 user ESP equals what the fuck? Yeah, fuck it. User ESP equals INT32 user underscore stack plus 4096, and now UINT32 underscore T user EIP, jump to user mode, user EIP, user ESP. I got whistle. Okay, so now we go make ISO, make disk, make run. I don't see it. I don't see it. What? Did I do something wrong? Static. What the fuck? Did I do it wrong? Did I put it in the wrong area? Is it meant to be in the actual loop? Aha! Fuck. What? Sorry. What? Fuck.
He's a semi-aquatic, egg-laying mammal of action. He's a furry little fretfoot who'll never flinch from a fray. He's got more than just mad skill. He's got a beaver tail and a bill.
Fuck it. Boom.
Whenever they hear him say,
Hey mate, ISO make this make run. Hell yeah. What? That's not good. The fuck? That's
he's got an iron will, a nerves of steel, and several other metal-themed attributes. His fur is watertight, and he's
what the fuck?
so when evil hears this sound, it shakes in its boots.
What the fuck is going on?
He's got more than just mad skill. He's got a beaver tail and a bill. And the women swoon whenever they hear
Okay, I think I'm tired. I'm gonna end it here. Thank you all, and by all I mean literally one person. Thank you all for coming. I'll be going to bed now. Like actually, I'm tired. I need rest. Nah, it's fine. All right.